Pamela. Welcome to my channel. Today I'm gonna talk about when the tank is closed and under pressure, a tube is connected to the upper part of the tank and the pressure difference between the upper and lower intake is measured using the transmitters that we can see in this image. This is because it is necessary to correct the indication of the device for the pressure exerted on the liquid. If the pressure is great, the measurement will not be exact. When gases or vapors above the liquid are condensable, the line from the upper intake is gradually filled with a condensate until the entire tube is filled. Therefore, the pipe to the right of the transmitter will have more pressure than the one to the left and will mark low when it is high or vice versa. To solve this, we must set the instrument in reverse. That is, for pneumatic transmitters, it must indicate 0% at 3 psi and 100% at 15 psi, or 0% at 4 milliamperes and 100% on 20 milliamperes DC. Another way to use it is by using a differential pressure cell with a suppression spring, which is applied to the transmitter's force balance bar and produces a force equal to the difference of the maximum and minimum level. The spring tension can be adjusted depending on the case. In digital instruments, a special zero suppression algorithm is used. When fluid can vaporize at room temperature and operating pressure, the equalization line can be plugged if the fluid is not clean. To solve this, the line can be purged, but is not recommended due to the maintenance problems and possible loss of accuracy. Then, another option would be to use a differential pressure transmitter attached with two capillaries to two diaphragms connected at the top and bottom of the tank. It is important that both diaphragms are at the same temperature to avoid measurement errors due to the expansion of the fluid contained in the capillary tube. If the tank is elevated and the meta is in a much lower part, the column of liquid that goes from the minimal level to the meta is greater than the variation of the level itself, so its appreciation is made on a very small part of the scale. To correct this, elevation springs are used, which are applied to the transmitter's force balance bar and produce the force that adjusts equal to the column of the liquid that I mentioned. As with zero suppression, digital instruments have an algorithm for zero elevation. In case of reactors or tanks in which the product can polymerize or solidify if the temperature drops, differential pressure meters with diaphragms extended by two capillaries connected flush with the inner wall of the tank in the upper and lower parts used. If this does not happen, the transmitter can be left more outside the tank to add an isolation valve to be able to disassemble the transmitter. When the fluid is very viscous, the membrane can be immobilized by the solidification of deposits, which is avoided by measuring by purging, inclusion, etc. by installing regulating rotameters and check valves in both intakes. For fluids, arm rotameters are used, and glass rotameters are used for non-toxic and non-dangerous gases. Differential pressure meters can also be used to measure interfaces. The amplitude of the measurement is given by the pressure difference over the element diaphragm. First, with the tank filled with the densest liquid, and then with the least dense. For example, if the interface is water kerosene and the tank is 3 meters high, the available differential pressure will be the one calculated on the screen. This can be easily measured by using a sensitive differential pressure transmitter fitted with an elevation spring to compensate for the initial pressure of the less dense liquid. The accuracy of differential pressure transmitters is plus minus 0.5% for pneumatic ones, plus minus 0.3% for electronic ones, plus minus 0.15% for smart ones with 4 to 20 milliamperes DC output signal, and plus minus 1% in those used in open and closed pressure and vacuum tanks. As advantages, they have no moving parts inside the tank. They are easy to clean, accurate, and reliable. They admit temperatures of up to 120 Celsius and are not influenced by pressure fluctuations. The bad thing is that in closed tanks, they face possible condensation of the tank vapors in the connection tube to the instrument, which can be solved as I already mentioned above. Suitable materials for these instruments must resist the corrosion of the liquid and can be 316 stainless steel, Monel, tantalum, Hastelloy V, and Teflon-coated stainless steel. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adiós. Differential pressure.